And then we have to start encapsulating our data. So the first thing we do is we put on our UDP header information. Our port number, source and destination port number, is going to be part of that header. And then we have to pass it down to the internet layer of the TCP/IP stack, or what? The network layer of the OSI model. So UDP header is done at the transport layer, creating a segment for us. And then right here, we are doing our encapsulation for our layer 3 packet. So keeping things simple, you can see your layer for the OSI model. You'd have layer 7, 6, and 5, layer 4, and now we're dealing with here, layer 3 of the OSI model. So this entire encapsulation here is creating our packet. In the packet, what do we put? We put IP addresses. So I need my source IP address, which is 192.168.3.1. And I need my destination IP address, which is 192.168.4.2. And how did we get that? We got that through DNS. Or we typed the address right into that application at the time, or at the beginning of this process. So what do we do now once we have our packet? We need to create our frame, don't we, for Ethernet? And what do we need? What do we need in our frame when we are on an Ethernet network? Give you a hint, we need 2 addresses. Source, MAC address, that's right. And who is that going to be in this case? Who is the frame? It's coming from PC1. So our source MAC address is going to be this right here. Now, who is the frame going to? Who is the frame going to? Did you say PC2? Did you say PC2? Let's pause here for a moment. If you said PC2, back up a moment and remember this packet here. The packet is going to PC2, but the frame is for communication in our local area network. The frame will never go beyond the router's interface here. Never. So if the frame's not going to go beyond that router interface, then who is the frame going to? Yeah, the frame's going to our router, our default gateway. So the frame is going to stay within the local area network. The packet is going to continue on the journey. So we need the MAC address of who? Not PC2 in this case. We need the MAC address of our default gateway. Now, how do I know I need the MAC address of my default gateway? Because when I look at this destination IP address, 192.168.4.2, PC1 says, is that part of my local area network? So it's going to figure it out. It's going to say, based on my local IP address of 192.168.3.1 and my subnet mask of 255.255.255.0, what is my network ID? My network ID is 192.168.3. What is the network ID then of PC2? Does it equal my network ID? Well, when it looks at PC2 here, it says 192.168.4. Well, no, I'm in 192.168.3. That means .4 is another network. And in order to talk to somebody in another network, I have to send the frame to my default gateway. So the source MAC is going to be PC1's MAC address, but the destination MAC address is going to be that of the router's interface that is part of the local area network of PC1. So we need to figure out the MAC address of our default gateway. So if we don't already know the MAC address, how do we check for that? Well, our PC would check what is known as an ARP cache. Do I have the MAC address of 192.168.3.2 in my MAC address table? Sorry, let me repeat that. Do I have a MAC address entry in my ARP cache for 192.168.3.2? So the PC is asking itself, do I already have in my ARP cache an entry, the MAC address for 192.168.3.2, which is the default gateway? And in this case, the answer to that is no, right? We're saying no. So what do we need to do now? How do we figure out the MAC address of our default gateway? We need to send out an ARP request. An ARP request. So the ARP request is going to be a completely separate process here. So we take our current packet and we go ahead and we just put it aside. That's right. We put it aside, and now we need to do another process. And that process is an ARP process. So we're going to send out a request, and that request is, I am looking for the MAC address of my default gateway. My default gateway happens to be 192.168.3.2. So if you are 192.168.3.2, send me your MAC address. So here's our ARP request. The ARP request has a source of what? Of my local MAC address right here. And what's the destination of this ARP request? It's broadcasted. Look at that. It's broadcasted. ARP requests are broadcasted. Why? Because I don't know the destination MAC address, or else I would not be using this process. So I'm screaming out to absolutely everybody in my local area network, hey, if you are 192.168.3.2, give me your MAC address. Thank goodness broadcasts will never cross router interfaces. So that broadcast will stop right here. It won't go any further than that local router interface. Routers always stop broadcasts right there by default. So not allowed to pass. So everybody in that local area network is going to receive it, but only the owner of 192.168.3.2 responds, and that's my router. So my router will then respond back with an ARP reply. So it receives this ARP request, and what is it going to do? Well, it's going to do two things. It says, this is for me, and I need to reply to it. But before I reply to it, I'm going to make an entry in my ARP cache. You see, I just received this ARP request from a device with an IP address of 192.168.3.1. And that device sent this ARP request from this MAC address. So the router now is going to make an entry in its ARP cache saying 192.168.3.1 is reachable using 080002222222. So not only is PC1 going to learn about the default gateway's MAC address, but the default gateway is now going to learn about PC1's MAC address as well. So it's bidirectional learning here, even though PC1 triggered the process.